Now, I don't know if that's true or not, but I would like to just hear quickly, what is your opinion of fractions? Today what we're going to be doing is eliminating fractions from equations. We know how to solve two-step equations. We know how to simplify both sides. We know how to gather the variables. So today we're going to look at what happens if there's a fraction. And as I said, we know how to simplify. Use the distributive property, combining like terms. Both halves of the equation, one expression than the other. We know how to gather all the variables onto one side if we have variables on both sides. So eliminating fractions is kind of what's up next, because between the three of those, that will allow us to turn pretty much any equation into, or any linear equation I should say, into a two-step equation, which we know how to solve. So once we have this, we can look at problems that are as complex as we'd like, and we have all the information we need in order to solve them. So first things first, because fractions are, let's face it, the F word as far as math students are concerned, we just want to stop thinking about these as fractions. And really that's acceptable because fractions are just division problems. There's nothing else to them. So in order to undo division, we know how this works. The inverse operation of division is multiplication. So what we do is we multiply both sides of our equation when it has a fraction by the denominator, the bottom part of the fraction. And our best bet is to do this once the fraction is by itself on one side of the equation. So again, all we're going to do is multiply both sides by what's on bottom of the fraction. So let's take a look-see. We have here the equation 3x plus 2 over 5 equals -2. And we want to simplify this, get it down to where we can do something with it, hopefully turn it into a two-step equation. And what we see is that on this side, the left side of the equation, we've got an expression that is just a fraction. When this happens, if we multiply both sides by the denominator, what's on bottom of the fraction will disappear. And here's why. Remember, we said inverse operations cancel each other out. It leaves you with an identity. So in this case, 5 multiplying by 5 and then dividing by 5 is the same thing as multiplying by 1, which changes nothing, which means we can just eliminate them, make them go away, because they're not changing anything. So when I multiply by 5, that cancels out my dividing by 5, leaving me with just 3x plus 2. And on this side, -2 times 5 would be -10. And now from here, what I can do is just solve the two-step equation. I have multiplication and addition. I undo the addition first, and so I end up with 3x is equal to -12. Divide both sides by 3, and I find that x is equal to -4. That is my solution. That is the statement that makes the equation true, and I can check and verify that that is correct. Substitute -4 in for x. 3 times -4 is -12. -12 plus 2 is -10. -10 divided by 5 is -2. And so we can see that once we multiply by that denominator, everything else gets a lot more simple. So let's check this one out. -x minus 4 over 3 plus 2 equals 17. Now remember, a couple slides ago I told you that it is best to wait until the fraction is by itself on one side of the equation before we multiply by the denominator. Well, here that fraction is not by itself. It's got a plus 2 with it, and we want to make that go away. Well, we know how to do that. We simply subtract 2 from both sides, leaving us with -x minus 4 over 3. These eliminate each other. 17 minus 2 is 15. Now my fraction is all by itself over here on this side, and I am free to multiply by the denominator. And again, denominator just means the part on bottom. By the way, the part on top is called the numerator, so if you hear me refer to that, that's all that means. Multiplying by 3, dividing by 3, cancel each other out. I'm left with negative x minus 4 equals 15 times 3, which is 45. Now it's just a two-step equation. I add 4 to both sides, and I find that negative x is equal to 49. Well, negative x, that means negative 1 times x, so I can divide by negative 1 to get rid of that negative sign, and I would find that x is equal to negative 49. And again, I can always substitute that back in and check it. So now let's make things really fun, and this is sort of the beating heart of this lesson. This is where I wanted to take this, is what happens when you have fractions on both sides of the equations. On the left and the right, there's just fractions everywhere as far as the eye can see. This situation is called a proportion. And when we solve a proportion, we're going to do exactly what we just did. You multiply by the denominator from one side, and then you multiply by the denominator from the other side. But it turns out there's a nice quick trick for doing this in a more efficient way. It's called cross multiplication. So on this first proportion that we will look at solving, I'm going to show you two ways to do this. I'm going to show you the way where it's multiplying by both things that are on bottom, and then I'm going to show you what it looks like to do it using cross multiplication. So I'm going to divide my screen into two halves here so that I have two places to work, and let's start by doing the trick that we just did a second ago. I have a fraction over here, it's by itself, so what I'm going to do is I'm going to multiply both sides by that denominator. So over here they cancel out and it leaves me with 2 equals, and then when I multiply, I can just multiply that in by what's on top, so that would be 3n over 9. Well, now I have a fraction over here, so I got to multiply both sides by 9. 9 times 2 is 18. These cancel out, and it leaves me with 3n. And now this is simply a one-step equation. I've got to get rid of the 3. And so I divide. 18 divided by 3 is, of course, 6. These 3's cancel. And lo and behold, n is equal to 6. So this is the way to mathematically properly do it. I'm multiplying by the denominator on one side, get what I get. Multiply by the denominator on the other side, get what I get. Now let's look at cross multiplication, because it's really just a shortcut to do the exact same thing that I did right there. Most people, however, don't understand where the shortcut comes from. So here's the shortcut for cross multiplication. Take the top part on the left side, multiply it by the bottom part on the right side. So 2 times 9, and that's going to be on our left side of the equation. Then I take the denominator on the left times the numerator on the right. 3 times n on the other side of the equation, and that is the cross multiplying. I multiplied across the equal sign this way and across the equal sign that way. And notice what I'm left with when I multiply this out. 2 times 9 is 18. 3 times n is 3n. Notice that leaves me the exact same step that I got to right there. These two things are exactly equivalent because cross multiplying is literally doing the exact same thing that we did over here. And of course, if they're exactly the same, when I isolate n, I find that it's still 6, because of course it is. So now let's look at this thing getting really, really complicated. Now I have 2 terms on the top part of this fraction, and I am going to be cross multiplying. So let's take a look at what that looks like right now. First, I'm going to cross multiply these two, and here I have to be very, very careful, because when I multiply these, this 4 is getting multiplied by both the x and the negative 8 right there. So in order to write that, I would write it as 4 quantity x minus 8. It's the distributive property. And when I go to write the other side, equals, well, 2 times 2 is simply 4. And we know how to solve equations like this. First, we're going to distribute, so that I would get 4x minus 32 is equal to 4. Now it's a two-step equation that we are all more than capable of solving. So we've got 4x is equal to 36 divide both sides by 4. We want to undo that multiplication, and 36 divided by 4 is, of course, 9. As always, you can go back and check your work. So if we take x equals 9, 9 minus 8 is 1/2. And 1/2, if you were to do 1 divided by 2, you get 0.5. If you do 2 divided by 4, you get 0.5. So those are exactly the same. Finally, our worst case scenario, I say worst case scenario, it works exactly the same as the others. What we're going to do here is just cross multiply, but we're going to end up with 2 distributive property problems. And that's okay, because we know how to do that. And you'll have variables on both sides, but hey, we know how to do that too. So we're going to cross multiply here. We get 3 times m minus 7 for the left-hand expression equal to, and then we multiply across there to get 9 times m plus 4. Get rid of that mark right there, because that'll bother some of you. Now we need to distribute both of these. So when we distribute this 3, remember we're multiplying by both of those. 3 times m is 3m. 3 times negative 7 is negative 21. And then the same over here, 9m. 9 times positive 4 is positive 36. Now I have variables on both sides, so I want to gather those variables. I'm going to gather them to the side of the larger one, so let's get rid of this minus 3m over here. These will cancel because they're inverses. And again, negative 21 is equal to 9 minus 3 is 6m plus 36. Yay, two-step equations. Subtract 36 from both sides. But you guys don't actually say yay when it gets to a two-step equation. Shameful, shameful. And so here I get negative 57 is equal to 6m, and divide both sides by 6, and what I get is m is equal to negative 57 over 6. That does not come out even, but you know what? That is okay. It is acceptable to get fractions or decimals as your answer. It is also acceptable to present them as either. If you want to present that as a fraction, sure. If you want to present it as a decimal, sure thing. They mean the same. We might as well use whatever form we're comfortable with. So to recap and to wrap all of this up, when we have equations with fractions, what we want to do to get rid of those fractions is to multiply by the denominator. And in particular, we will do this as many times as necessary. So if we have what's called a proportion, where I have one fraction equal to another fraction, what I'm going to do is multiply by what's on bottom twice. And we can shorten that process using this technique called cross multiplying, where I would take the top times the bottom of one side equal to bottom times the top of the other, 3 times n minus 1, and then we're going to distribute all that. You get 4n minus 24 is equal to 3n minus 3. Gather our variables. So in this case, I'm going to get rid of the smaller one, which would be 3. And I'll work this up here so we have a bit more room. 4n minus 3n is just 1n minus 24. 3n minus 3n cancels each other out, and I'm left with just a wee little one-step equation to which I can find that n is 21. But again, when you have a fraction, multiply by the denominator to eliminate the fraction. If you have a proportion, simply cross multiply and solve whatever equation shows up next. Good luck.